Okay, so now we're going to graph more with vertex form, but I want you to see what happens with what's called transformations or translations is what we're going to actually be doing. So in order to understand that, let's start back with the parent function. So remember our parent function is x squared, and we're just going to start with -2 to 2. And if I plug that in, I'm going to get -2 squared, which is 4, -1 squared, okay, 0, 1, and 4, okay? Let's plot that. That's going to be 0, 0, 1, 1, -1, 1, 2, 4. So this is our parent function, and that's going to come in really handy. We need to know what these initial points are, but is it very difficult? No. You're just going to plug in -1, just plug in the 2's, 1's, and 0, and you're going to see that it's going to be that U shape, like we talked about yesterday. It's a parabola, so it's a U shape, okay? Our vertex, of course, is 0, 0. And our axis of symmetry would be the y-axis, okay? So there's our vertex. And you're going to see that in your packet I've crossed off some problems because I rethought about how it would be better to teach it. And so I've gone through and also eliminated some things since we're a little shorter on time. So that's our vertex, axis of symmetry. Notice that our vertex for our parent function is the same as our y-intercept. So just to point that out to you too. But you're going to want to know these 5 points because we're going to use them later on. So the next thing we're going to do is I'm going to actually have you go to your computer, and I'm going to open up that computer too, and I'm going to teach you how to use Desmos because it's really awesome. So when you go to desmos.com/practice, this is the screen that you will see, and the reason we're using it this way is because this is the graphing calculator that you'll be able to use when you take the EOC. You'll be able to actually use this graphic calculator, and you're going to see why that's so cool. So we're just going to practice some problems, and I gave you some to start with. So the first one I want you to type in is y, and you just, on your keyboard, type in y equals x squared. Now to get a squared, okay, so see once you type that in, it gives you a line. We need to get x squared. So see right down here, see that keyboard, you're going to click on that. And then all of this stuff shows up, and you can do lots with this. We're going to use this right here, but before we go any further, notice that you can just type in x and y. I could do all of my keystrokes right in here to have entered that equation. I'll do that on the next one. If I go here, that gives me the alphabet. So if I needed to type in anything else, I could. It gives me brackets. It gives me both square brackets and squiggly set notation brackets. It gives me some other symbols I'm not going to be using. There's a percent and factorial. We're not going to be using those. So let's go back to the numbers. But it will also give me other functions. These are all trig functions. And then we have stats functions and distance functions and miscellaneous. So look at that, distributive functions. There's a histogram and a dot plot. You could actually put them in there. That might be helpful. If you have to make a graph, you could actually make it right in there. Other statistics that they have, not ones that you're going to be using too much for your test, but they are there if you would need them. Let's look at the miscellaneous while we're there. If I need to do a square root logarithms, integrals, no, probably not too much. So anyway, that's what's in the function. So if I want to square something, I'm going to click on this button right here, see where it says a squared, and notice it's going to give me that parabola that we just graphed. That's your parent function. So I want you to graph another function. So go over here, see where that number 2 is. I want you to click on that, and notice another equation shows up. This time I'm going to put it in using the keyboard. So y equals x squared plus 3. Okay, see what that graph looks like. We're going to talk about that in just a second, what's happening with the graph. I want one more equation from your paper. We have y. Now I notice the paper says f of x. That's the same thing. So I'm typing in this one, and I'm going to use my keystroke, minus 2. Okay, so here the red one, that, and notice that this one can go in and out. I didn't mean to do that. Hold on. I want to go, oh gosh, here we go. Okay, so here, that red one, and notice I can put points on there if I want to. Here's the 0.11, so I can do that. See how that's the point? Oh, if I want exactly, I need to move down a little bit. But if you click on it, it will say what point you're on. See how there's 1, 1. The reason that's really helpful is because if you ever want to find a point, a whole number point, see how we can just click on it and it will tell us what that ordered pair is. Okay, so the red one, that's your parent function, and then the blue one was y equals x squared plus 3. Look at what happened. Compared to your parent function, what's happening? And then the last equation, x squared minus 2, here's my parent function in red, and then notice what it does. It drops down to this green one. Okay, so write the generalization. We'll come back to this. Write the generalization for what did you see happen. What did you see happen right there with all those functions? Okay, notice that with this one, plus 3, so with plus 3, it went up 3. And with minus 2, it went down 2 places. Okay, so it shifts the graph. Shifts the graph from the parent function. Shifts from parent function. That's supposed to say parent function. Okay, let's go back to decimals, and now we're going to graph these. And remember, this is just y. Okay, y equals, y equals, y equals. Let's go back to decimals now, and we're going to graph those. So to clear the equation, just click on the x. Not anything too scientific there. Oops, I cleared it completely. That's okay. Doesn't matter. So now I'm going to put in my parent function again. So that would have been wise to just leave that, but I didn't. X squared. Oh, but I get a different color. So now my parent function is blue. I'm going to do another equation. So now I'm going to do y equals, I type that in, and then come down to parentheses, or I could just type it in. Why is it giving me that? So notice when a problem came up, I got that little warning sign, and I just clicked on it to see what the problem was. I know I don't want my parentheses empty. I'm going to put stuff in there. So x plus 1 quantity squared. So I have to click on the outside of it, and I'm going to square it. And notice what happens there. That's my second equation. What's happening? If you want to see what those points are, we can move it out a little bit. Okay, that's the black one. Now I have y equals parentheses x minus 5 parentheses squared. What happens there? Oh, we can't see it. It graphs somewhere. Oh, there it is. There it is. We found it. Okay, so you can just use your fingers to move in and out. We had one more. Y equals parentheses x plus 8 and parentheses and squared. Okay, so look at what happened with those. Look at what happened. What would be your generalization? Look at what's going on. Okay, so my parent function is right here. When we had y plus 1, it moved this way to the left. When we had x minus 5, it moved to the right. When we had x plus 8, it moved to the left. So if we go back to our generalizations, okay, our generalization, what happened to the graph compared to the parent function, okay, it shifts left and right. So we know that this one shifted up left and right. This one went up and down. This one went left and right, okay? And notice, too, with this, that what is happening is that if I have a positive inside, it goes left. It's like it goes to the opposite direction. And if I have a negative or a minus, so this would actually be a plus sign, sorry, plus and minus. Okay, notice when we had a minus 5, it shifted to the right. When I had a plus 8, it shifted to the left. So it's kind of like what I like to think, I know, quirky and weird as I am, I think of what's inside these parentheses as an opposite machine. So if I remember that this is always going to go the opposite of what it seems like it should, if I have a minus 5, it's going to actually go to the right. And it has to do with if I were to solve this and everything else. We won't get into that. So the next thing I want you to look at is yesterday, in the last lesson, we talked about vertex form. And this is what vertex form looks like. Quantity x minus h quantity squared plus k. And if we look at what we just did, notice that inside the parentheses did a horizontal shift. Okay? Whereas on the outside of the parentheses, that did an up and down shift. So k shifted up and down. and H shifts it left and right. And with the H shift, okay, it's going to go the opposite direction. Opposite direction. Okay, so using vertex form, this is going to shift it horizontally. This is going to shift it up and down. So I remember H is horizontally and the other one is just up and down. So that's how I remember them. So in vertex form that we learned about yesterday, okay, this is what it looks like. This shifts it left and right, up and down. Let's go to the next page. So go to page 17. Where did my page 17 go? Right here. On page 17, I want you to skip down to right here. We're going to start right here at where I have f of x equals x squared, 2x squared, 1/2 x squared. Okay? I want you to go to Desmos. And I want you to graph these equations right here. I want you to graph these equations. I'm going to get there. I've lost my mouse, so I'm going to pause. There it is. And this time I'm going to be smarter. I'm going to leave my parent function. Okay, so I've got my parent function, x squared. Now I'm going to put in the 2x squared. So y equals 2x squared. Don't worry about it yet. It's going to go away, 2x squared. Okay, now wait, what was the parent function? Let's look over to the side. See how the green one is the new one. The purple one is my parent function. And notice what happens when I do y equals 2x squared. So notice what's going on there. Okay, let's go to our third equation. Well, let's just talk about this. Notice that it gets skinnier. It's a skinnier one. And we'll talk more about that, but just notice that it gets skinnier. The last equation is y equals 1/2. And notice what it does for us. 1/2 and click to the side of it. X. See how I had to move that cursor up? So x squared. Okay, now this is a little hard to see. My parent function, I wish I could change the color on that, but I can't. This is my parent function on the inside. Can I change the color? I used to be able to change colors. I'm going to pause and see if I can. So I was able to change the color, and I'll tell you how to do that in just a bit. So I want you to see the blue one is the parent function, the green one is the second equation, and the red one is the 1/2 x squared. So when I have 1/2, notice that it gets wider. When I have a 2, it gets skinnier. And what is happening there? Well, okay, so notice that. Now we're going to go to the next set of equations. And I'll show you how I change the color if you want to. When I click out of it, okay, when I click out of it, it's going to give me a different color. So if I want to keep it green, when I type in, so now we have the equation y equals 4x squared, okay, it gave me a different color. If I don't like that color, I'm just going to click out of it. And I'm going to come back and do that exact same equation if I want a different color. Y equals 4x squared. Yeah, it's a little work, but no, now it changed to a green. There's not a lot of colors they're going to change to. So now I'm going to have y equals 1/4. And the way I type that in is 1/4. And I don't see another way to do that right now. Then move my cursor. So I just typed in 1/4. And then x squared. And see how that's too close of a color. So I'm going to click out of that and type that equation again. It just makes it go away. I'm going to type it in again. Y equals 1/4. Move it up. So now it's black, which is fine. We'll just do that. Okay. So now look what happens. Again, so the blue one is my parent function. The green one is y equals 4x squared. And the black one is y equals 1/4 x squared. Notice the fraction makes it wider. The whole number makes it skinnier. And we're going to talk about how we do that. So here's one way you can think about it. If I have a fraction of 1/4, okay, see how mine is wider? That's because it takes 1/4 as long to get to the next point. It takes 1/4 as much time to get to the next point. And when we have some time, I'll explain more about graphing those. I just want you to see what happens for today. When I have a 4, it goes up 4 times faster. So see how it goes up really fast. If I look at my points, and this is one of the things that I'll do on the paper, if I look at my points, here is the point 1, 1, But if I look at where that first point in here, it goes all the way up to 4. It's 4 times higher. My y value gets multiplied by 4. Here, my first point, it gets multiplied by 1/4. So it says what we call, it gets wider, and we have narrow and wide. The whole numbers make it go narrow. The fractions make it go wide. We talk about this as a stretch. So 4 stretches it. This one shrinks it, so it makes it go up less fast. Okay, let's go back to the paper. I just wanted you to see what was happening with those. So now let's make our connections. What did we see happen? We noticed that with the whole number, it goes up fast. And the way we're going to think about that too is this one is narrow. Okay? With the fraction, oh, hey, wait, look right down here. Let's just skip down here. Okay? If A is negative, it opens down. Okay, hold on. If A is greater than 1, meaning that it's a whole number, okay, this is what we call a stretch. It goes up faster. So it's going to stretch it to be skinnier. So it's going to stretch it out really fast. I'm just going to take and stretch it. So it will go up faster. We're going to multiply the y, multiply y coordinate by a in order to find out the new point. That's an a. Okay? If it's a fraction, if it's between 0 and 1, it's going to be that it shrinks it. What we say is a shrink. This one is going to be wide. Okay? This one is narrow. I should have put that. So this one is narrow. If I have a whole number, this one is wide. So this one takes longer to go up because you're multiplying it by a fraction. Multiply the y coordinate by a, by that fraction. Okay? So now we're going to go back to the page we were just on. And we're going to go right here, steps to graph the function. We're going to use this vertex form. We're going to use our stretches. So first off, I'm going to pause, and you pause too. I want you to copy down what this says. State the shifts, stretches, and how does it open. Plot the parent function, and apply the shifts. Write that down, go. So we're now going to graph using our stretches and our shifts and our parent function. So the first thing I want to do is, what are my shifts? Well, notice, okay, vertex form, y equals x minus h quantity squared plus k. So this is the opposite. So this is going to go, instead of, it looks like it should go right, but it's going to go left 3 and down 2. Okay? Those are our shifts. We don't have an a other than 1. So what we're going to do is next is we're going to plot the parent function. The parent function is 0, 0, 1, 1, negative 1, 1, 2, and 4. So I've just plotted y equals x squared. I'm just going to plot the points. Don't draw it in. That gets too confusing. Just plot the points. Plot the parent function. Now we're going to apply the shifts. So what we're going to do is we're going to take each one of these points and we're going to shift it what it says here. So my vertex goes left 3, 1, 2, 3, and down 2. Every point shifts left 3, and it doesn't matter if you go down 2 and then left 3. Just do these two. So I can go down 2, left 3. Okay, every point goes and gets shifted. Every point, 1, 2, 3, down 1, 2. 1, 2, 3, down 1, 2. This is my actual, look at the red. This is my actual graph. So what I did is I shifted the parent function. Here's the parent function, and I just shifted it left 3 and down 2. So if I can plot the parent function, I just do the shift. Now, on the EOC, one of the things it's going to ask you is it's going to give you an equation like that. And it's going to say, or it's going to say, I'm going to change things. They're all about the shifts. They're going to ask you, how does that change the equation, or how does that change the graph if I shifted this, or if my parent function is such and such. And so they're going to ask you questions. I don't know what this is. That's supposed to just be 1. Okay, so that's all you have to do. It's graphed. Done. Okay, here we go. Let's write down our shifts. So this is negative, so that means it's going to go to the right. So this one's going to go right 1, down 3, right? Correct? Okay, so let's plot the parent function. 0, 0, 1, 1, negative 1, 1, 2, and 4. That's our parent function. We plotted it. That's step 2. Now we're going to take our parent function and we're going to shift it according to this. So we're going to shift it right 1, down 3. Okay? Right 1, down 3. Right 1, down 3. Right 1, down 3. Right 1, down 3. Oh, that's a part of our parent function. So this is my graph. Not supposed to be going through that point. It should just go right by it, but not through it. There's my graph, okay? Because I just shifted my parent function. Here's my parent function. And I just shifted it right 1, down 3. Okay? Good. Let's do some more. And I would love it if you would pause yours right now and write down those shifts. I'm going to pause mine. I'm going to write down the shifts, and we'll come back and compare. Go. So notice inside is a plus, so that means I know I'm going to go the opposite. I'm going to go left 5 and up 4. So plot the parent function, 0, 0, 1, 1, 2, and 4. There's our parent function. Okay, we plotted our parent function once again. Now we're going to apply all of our shifts. We're going to go left 5, 1, 2, 3, 4, 5, down, oops, up 4, 1, 2, 3, 4. Okay, left 5, 1, 2, 3, 4, 5, up 1, 2, 3, 4. Now, notice the distance between these. I can just kind of do, here's my axis of symmetry. I can just do a reflection point. So I can do it that way too. Or I can keep going. Left 5, 1, 2, 3, 4, 5, up 1, 2, 3, 4. Left 1, 2, 3, 4, 5, up 1, 2, 3, 4. There's my graph. Okay, now I want you to notice. What's my vertex? Well, my vertex is negative 5, 4. Okay, so I could do it that way too. I'll show you what I mean by that. Let's look at our vertex. Nope, we're going to go through the same way. Shifts. Do it all the same. Shifts. I'm going to shift right 6 and up 2. Okay? So plot your parent function. 0, 0, 1, 1, negative 1, 1, 2, 4. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. There's my parent function. Now, I'm going to do the shifts, but before I do the shifts, I want to show you one other option. Another option is you can plot the vertex. The vertex is negative 6, 1, 2, 3, 4, 5, 6, 1, 2. Because this is the vertex of 6. I went wrong. I'm wrong. The vertex is 6, 2. That's my vertex. So my vertex is 1, 2, 3, 4, 5, 6, 1, 2. There's my vertex. I can shift all my points, or the other option is I can plot my parent function right here. So if I plot my parent function right here, it's kind of like I do a little axis right here. I just kind of make my little axis right here as to what's happening. And then I go, well, I need 1, 1, negative 1, 1, 2, 4, and 2, 4. This is my graph. Now, if I would also go back to the way I've been doing it, take my parent function, I shift it right 5, 6, 1, 2, 3, 4, 5, 6, up 2. Take this point, 1, 2, 3, 4, 5, 6, up 1, 2. Okay, I'm just shifting all these points. It's just another way to look at it. Okay, questions? Okay, so now I'm on page 18, and now we're going to add in A. So H still is the horizontal shift. K is a vertical shift. Okay, horizontal shift. Horizontal, this is the one that goes opposite. Okay, and so if I have a plus, I'm going to go left. If I have a minus, I'm going to go right. Vertical shift, if I have a plus, I'm going to go up. If I have a minus, I'm going to go down. A determines how it opens. So if A is positive, it opens up. Remember we talked about the smile. It opens up. And if it's negative, it opens down. But A is so powerful, it also determines if A is greater than 1, it's going to go quick. It's going to be narrow. And again, we're going to multiply that y-intercept by our A. And if A is a fraction, meaning it's between 0 and 1, then it's going to be wide. And what we do on both of these is we multiply the y-coordinate by A. And I'll show you that. Okay? So, look at number 5. So what we do on number 5, okay, is that we're going to have to do it in parts. But let's look at our stretches and shifts. It's going to shift. This one shifts. How does it shift? Okay, well, this is my horizontal, and it's a plus. And remember, this is like an opposite machine, so this is going to go left 1. And this is going to be a stretch. It's going to go narrow by 3. Okay, I know this is a long video. Stay with me. Plot the parent function. 0, 0, 1, 1, 2, 4. Okay, we're going to take off this shift. I'm going to change this equation because it's too much at once. Y is equal to 3x squared. We're just going to do a stretch. If I do a stretch, what I do is my y coordinate. So I'm going to look at just my y value. My y value is 0, 1, and 4. I'm going to do a stretch of 3. And if I do a stretch of 3, I multiply all of them. Well, 0 times 3 is 0. 3 times 1 is 3. 3 times 4 is 12. So we're not even going to see that point. That's how quickly this thing goes up. So we're only going to be able to plot 3 points. So if I plot this stretch, I plot 0, 0. But now instead of 1, it's going to go all the way up to 3. 1, 2, 3. So this point stretches up to here. And here's its reflection point. Then my next one is all the way up here at 12. We're not even going to worry about it. So here's 10, 11, 12. Okay? So when this point right here goes all the way up to 12. Okay? This point goes all the way up to 12. So my graph, when I go to graph it, it goes up so quickly I barely have a rounded at the bottom at the vertex. That's what the graph looks like. Okay. I'm going to stop there just because it's a long video. I would love it if you'd come into class. And also, if you have questions or if you want to see more of this, come see me during the help sessions because that will make a huge difference as to what's going on. I think that would help a lot if you graph some with me. So, okay, great. That's it for now. Check on Schoology to see what your assignment is. If you have questions, you know where to find us. Thanks.